Imagine you're looking at a beautiful SignalFx dashboard, and you see some metric, maybe it's CPU utilization, it seems to be humming along fine, and then all of a sudden it experiences a step change, and an engineer says, I would like a detector that finds this kind of behavior. That tells me when there's a level change. Okay, but I don't really care about what the axis is. I'm just concerned about this shape. Okay, so if you're trying to do this, you might first break up this window of the time series into two smaller windows. Okay, so you might say, well, how long? For how long do you want to see the step change? It's on. For how long do you want to see the step change? Is one value at a different level enough, or do you want to see it for a certain duration? And maybe we say, okay, well, I'd like to see this new behavior for 1 minute. Okay, and I want that to be different from the previous 10 minutes. So I'm just making up these numbers. Okay, so I want to know when the last minute is very different from the preceding 10 minutes. Okay, this is a common use case. Okay, and then one way to rephrase this problem of detecting a level change is comparing the distribution of values in this 10-minute window to this 1-minute window. Okay, so we might think of this as a problem of comparing distributions. Okay, and this is exactly, well, I mean, statistics is great at providing methods of doing this. Okay, so for example, we might take this 10-minute window and calculate the mean plus some number of standard deviations of the 10-minute window. Okay, we might view that as defining an upper range of normal values and compare that to the values in this minute. So we might compare that to the mean of the current minute. Okay, or we might say, well, this is I'm going to view something like this as an upper band on what's normal, and I would like to see all of the values in the last minute be above that, and that will correspond to comparing this quantity to the minimum of the last 1 minute of values. Okay, and then you might also say, well, maybe there's just a small. So let me draw the bands. So I don't quite know what it looks like, but it's probably something like this. So this would be the mean plus 3 standard deviations, mean minus 3 standard deviations of this 10-minute window of data. We might say, well, there might be a small dip below this threshold. So I only want to require that most of the values in the last minute are above that threshold. Okay, so you might say, let me compare the 10th percentile of the last minute. Okay, and that corresponds to, so if we think of this as the threshold, okay, then the first one is saying, well, the average in the last minute is above the threshold. This is saying all values in the last 1 minute are greater than the threshold. And this comparing the P10 of the 10th percentile of the last minute to this upper band is saying 90% of the values in the last minute are above the threshold. Okay? So there are various ways of, and there are other kinds of statistical tests you can do. So once you see a percentile here, you could say, well, maybe I want to compare the 10th percentile of this window to the 90th percentile of this one. You could also do that. You could also take into account the standard deviation of the last 1 minute and form a more involved statistic. That's fine. So now let me just pick one and explain how to do it in SignalFlow. Okay, so it's very easy. So let me just, well, which one do you want to do? let's use this. And then, do you care? Anyone want to pick one?
10%.
Okay, so let's do this one. Okay, so here's what it looks like in SignalFlow. So let's pretend this is some metric. So this is what the program would look like. So I might construct a stream by using a data block. So I say S is data of CPU utilization. Okay, and then this is really constructing a TSDB query. So I'm also allowed to put here filters and some other stuff, which is not that important. But I might have some filters. Okay. So this may have many streams if there are many emitters of this metric, and what I'll describe will just operate on them one by one. Okay, so I have some stream. Okay, and then the threshold is well, first I need to time shift because I want to get this window of data. So I need to time shift S by 1 minute. So that's just the time shift method. And I supply this with a duration argument. So I shift it by 1 minute. Okay. And now to this time shifted signal, I calculate my statistic. So for example, I take mean plus standard deviations. Okay. And then there are two arguments here. One is the number of standard deviations. So std devs. So let's make that 3. And then there's also a window size, an over. And here I've said that's 10 minutes. Okay, so this is my threshold. So I time shift my signal by 1 minute, and then I calculate mean plus 3 standard deviations of the trailing 10 minutes of that.
Do you need to assign that to a variable as well?
I could, or I could just plug this in an inequality. But let's assign it. So this is my threshold, T. Okay, and then let me also define, well, since I'm assigning that, I'll assign this P10 as well. So let me call it C for current. This is just the percentile of S itself, not time shifted. Percentile 10 over 1 minute. All right. And then I just want to detect when C is bigger than T. So if I want to create a detector, I can just write detect C bigger than T, and then I publish